Okay, so there's no homework for today, right? All right, you're supposed to go through, and so in general, are there any things that you want me to go over from this entire semester before I go through the slides? It talks about like what the exam might have on it.
Exactly what the exam might have on it?
Well, I'm going to go through. What? I just said that. Just tell me.
Exactly.
I'm not going to tell you exactly. I'm not going to tell you exactly.
Any actual like, programming stuff? Or?
There might be. It wouldn't be really complex programming stuff because it would be stuff you'd have to write by hand and C#y type things. But it would be possible. I might give you a scenario and say, how would you accomplish this? And then you kind of describe it more pseudocode-y. It would be reasonable to maybe ask you to instantiate an object, or maybe given a game object, change its position on the screen, something like that. So make sure you know how to work with like the transform and that kind of stuff. I might ask you to get a component programmatically and do something to that component, disable it or something like that. So it would be programming stuff along those lines. It would also be reasonable for me to give you some code that already does something and ask you to tell me, what does this do? And like in other classes, I'm not asking you to tell me line by line what each individual line does. I mean, you can do that, but I'm asking you to give me the, as a whole, what does this code accomplish? Something like that. So if I gave you like a working update method that did something, I'd want you to be able to read the code and give me a description of what this code actually accomplishes. You would say something like, once every frame, this is going to decide if the game object that the script is attached to is colliding with any other game object, stuff like that. Okay. I'm pretty sure that's anything else code-wise I might ask you to do. So you should be able to read code of any complexity. You should be able to write code of relatively light complexity. A couple of lines. Probably less than 10 lines, something like that. Yeah. And definitely, you should be able to create a. We've talked about JSON quite a bit more recently. If I were to give you like a C# object, like an example of a C# object, and ask you to generate the JSON associated with that. Instead of writing what I'm saying is you should be able to give me the JSON string that is the equivalent of an object. So if the object was first name, last name, and age, something like that, you would give me the curly brace, F name, colon this, L name, colon this, that kind of stuff. So be able to know the format of JSON would be an important skill to have. I probably would not ask you to do the same thing with XML. I mean, I would hope that you would kind of understand that the syntax different enough, but JSON is a practical skill set that would be used moving forward. It's not that XML isn't found. It's going to be found in older systems, but certainly JSON's more important if I'm going to use a couple of questions on the exam to cover something like that. It's probably going to be in the ballpark of JSON.
Yeah.
Make sense? Okay, so Any other high-level questions? You can ask more questions later after I go through the slides, but anything else high-level that you want to know about the exam? As usual, my exams will be 10 questions. It's going to be designed to last about an hour, give or take. So kind of a normal class period type thing. You have the full 2 hours to take it. So should not be a time crunch thing. I'm not going to, the exam is not going to feel different than my normal exams. It's going to be the same length, what I would expect you to finish in an hour. And if you're done in less than an hour, then you're done in less than an hour. All right. I don't want to grade some monster exam, and you don't want to take some monster exam. Is the punchline. And I can get out of you in 10 questions whether or not you've learned stuff or not. Okay. Our exam in here, just so we are all on the same page. Not that day, not that day. I'm guessing it's Thursday. Thursday, the 13th. At 7:30 a.m. in this room, bright and early. I would say I'd bring donuts or something, but there's a pretty high chance I'm not going to a store before this. But so I'm not going to bring donuts, but it did occur to me that I might bring donuts and decided that it wasn't going to make sense. I'll throw it as a 3% chance, and if I happen to be up early enough, I might swing by. There's a gas station by my house that has like Krispy Kremes or something. I'm 3%. So don't bank on it, but there may be food. Yeah. So, and the usual policy, if you do better on the final than you did on the midterm, I'll replace your midterm grade score with what you got on the final. So some of you could benefit from that as well. All right, so questions about the format of the exam in general? Makes some decent sense. Okay. So I'm just going to go through the slides, and some of the early stuff, I'm probably only going to pull things that are extra important, and some of those were already covered on the midterm. So, like for instance, I'm not going to ask you any sort of generic questions on what is game design. You know, at this point, that's should be in your wheelhouse. Nothing from this. I mean, you should certainly understand that game engines are based on physics and AIE type stuff, but I'm not going to ask you a question from related to this slide specifically. The final exam is going to be much more applied, either you showing me how to do stuff or you reading things that are being done. Okay, nothing there. And you certainly you're going to need to be able to read and write script stuff, but nothing here. One thing that just popped into my mind that I could see as making its way onto the exam is we've kind of recently dealt with kind of plain Jane C# objects as opposed to mono behaviors. So understand the difference between when we have a C# object inherit from mono behavior versus not. Why do the default scripts in C# inherit from mono behavior, and what abilities does that give us? And why did we not do that when we wanted to make our own objects for like representing patient records, or I don't know, what did we do this last time? I don't remember what we were representing in JSON at the end. Oh, yeah, that's right, the rooms and room collections. So why did we do those as normal C# objects versus children of mono behaviors? Yeah, nothing from this. If I had a throwaway question, I might ask you something about cross-platform. Unity is technically a cross-platform tool, so you can create it once, and then export it to the various platforms. Pretty low chance, but possible. Definitely the concept of a transform and position, scale, rotation. I probably would not ask you it outright like this. I think that was on the midterm. Just like tell me what a transform is and what are the three pieces, vector three. So you should know what a vector three is. You should know what a transform is. You should be able to identify it in code. You should be able to create it in code. It would be fair for me to ask you to create a vector three object and set a game object's position to that, something like that. So you'd have to know that that game object's position is contained within its transform and that the transform value for position is a vector 3 and be able to create a new vector 3 with the XYZ coordinate. I mean, I could ask you to, show me how to get the material component or something from a game object, but, we don't manipulate them or anything. So that would just be the, get component with the square or the angle brackets, material, something like that. Probably a higher chance I would do something with rigid bodies or collider or something like that because we've used those a lot more. Certainly know what a rigid body is. Again, it could make its appearance. There's a higher chance of rigid body showing up on the exam just in its normal form like this, but probably a better chance of me asking you more specific questions about rigid bodies, like the difference between like how does mass impact a rigid body? How are rigid bodies used in conjunction with colliders? What's kind of the difference between the two of them? That kind of stuff. And also reading code with the rigid body type stuff in there, where I might write some code that turns off some aspect of a rigid body, or maybe turns off the gravity aspect of a rigid body where it still has mass, and if it has a collider, it could still hit stuff, but it's not going to fall out of the sky because gravity isn't a component of it. Okay. And also the is kinematic side of things. So that's kind of used in conjunction with what we just talked about, where if you wanted to be bumpable by something else, you can make it as kinematic, which says your mass impacts other dudes, but you're not going to fall out of the sky. Okay? Otherwise, you can have a rigid body that hangs there and also doesn't interact with other things. That's reasonable as well. So questions that dig a little bit deeper into it. Certainly be comfortable with scripts, but I won't ask you to define what a script is. You'll have to be reading them or writing them and that kind of stuff. Same thing, frame rate. Probably won't ask you a direct question unless I'm trying to get a throwaway question, which I don't anticipate. Definitely know the difference between update and fixed update. Be on the lookout when I give you code examples and ask you, what does this code do? Whether I've used update or I've used fixed update for your answer. Your answer might be, every frame or 60 times per second for fixed update, something like that. So know the difference between those two, probably from the telling me what code does perspective, as opposed to just a flat out question that's what's the difference. Certainly understand the concept of MVC. Significantly higher chance this gets onto the exam in a more direct way. It's a really important concept. You hear me talk about it often in multiple classes. So I would potentially be inclined to use one question to ensure you understand what MVC is. Okay. So if I were looking for a borderline throwaway question, something that should be easy to answer, but I would ask this ahead of any of those other ones I mentioned already. I put a pretty high importance on MVC. And as usual, there will be at least one conversion question on the exam. If you ever have an exam with me that didn't have a conversion question on it, I forgot it. So, typically that. So like in here, it would be that. Yeah. So unless you're in a class where other conversions make sense. So for instance, like 325, when we talk about that later today, for a couple of you, that will bring into the thing possibly like data size conversions and stuff like that, from gigabytes to kilobits and that kind of stuff. But for us, it would be, convert some binary number into octal or that kind of stuff. And there would only be one of those in here. Certainly the idea of colliders, again, I might write some, ask you to do something with a collider programmatically, or I might give you some code and say, what does this do? So maybe be on the lookout for the difference of me checking for collisions inside of like an update versus versus like an on collision enter function that I might put in there, where we get notified when a game object collides with another game object. And I might ask you, what does that do? So the difference there being, I can either have a game object on every single frame say, did I hit something? Did I hit something? Did I hit something? Versus have a on collision enter where he gets notified whenever something hit him. And then he can look at what hit him in terms of its tag. So know what tags are. And decide, is this something I care about that hit me? Or do I just ignore it? Know what vector threes are. Certainly understand design patterns. I probably wouldn't ask you just the generic design pattern question, but MVC is a pretty important thing there. See, it's even in the slides twice. That guy's important. I might give you a collection of things in code and do something with it, and you should be able to tell me what's happening. I doubt I'd have you write code that uses, well, it would be possible. I could think about something that might ask you to use an array programmatically. I would say relatively high chance that I give you code examples that do something with arrays that you need to tell me what it does, but in the realm of possible that you might have to create one and do something if I ask you to write some code that does something. You should be able to instantiate an object and do something to it. So, I might say, I might show you a class or something and I might say that takes a public game object for like a prefab. And I might say, create an instance of this game object and set its position to some XYZ coordinate, that type of thing. Know what quaternions are. I won't have you do anything with rotation programmatically. If I have you read code that does something with rotation, it wouldn't be like a mathy specific thing. I might rotate something 90 degrees, for example, as opposed to, you having to give me some sort of quaternion, answer, because it's weird mathy stuff that humans really, the code does it all for us, right? We don't think in quaternions. Just when we see the word, we think rotation. All right. So, realistically, I probably wouldn't include it, but it's possible one of my code examples I might have a line that rotates, just like we currently have in our code a single rotation line to turn our room thing up, something like that. But I wouldn't ask you to write that, I don't think. Just kind of a wasted thing. If you had the documentation in front of you, you could just do it. So it's not a big deal. I do like coroutines. So you should be able to write a coroutine. So if I gave you an example, you should be able to write that little I enumerator thing. The very least, you should be able to read code that has one of those in it. Or if you remember from the midterm, I kind of gave you a scenario and asked you to give me kind of a way you could solve that problem. And kind of the most obvious solution involved a coroutine. So know the purpose of a coroutine if you want something to kind of happen on a timed kind of cadence, but not like an every frame or a 60 times a second thing. You would have more control over it. Coroutines make sense for that, where you can call a coroutine, have it wait for some amount of time, do its thing, and then potentially call itself again, that type of thing. So it's in its own thread, the idea of blocking versus not blocking, and maybe why we use coroutines, the idea that you only want to put so much logic inside of update, because update happens every single frame, so whatever logic you put in there has to complete in less than one frame. Kind of an important thing. So do you understand the concept of blocking calls? Understand game object tags. Again, you might have to write some code that has you get the tag from a game object and compare it to another game object's tag, or compare it to, is this the floor? Is this the player? Or something like that. That would certainly be fair game for code I would write and say, what does this do? So know what the purpose of a tag is. Should know what destroying does. I probably wouldn't ask you to write. Well, I guess it's possible. I might say if some condition happens, destroy the object, but the function's name is just destroy, and you put the game object in there. It's nothing, crazy fast, crazy or anything. But it's possible I would write some code that I destroy something when some event occurs. So you should know what destroy does. Deal with triggers for the difference between physics and no physics. So whether you want to know whether something overlaps without them taking mass and things like that into consideration and bumping off each other. So you might want to know if you come in contact with some element on the screen, some collider on the screen, without there being a visible reaction for things bumping off each other. So that's when you'd use a trigger with a collider. So triggers are specifically related to colliders, and is trigger means that we don't do physics. And then we would have that function on trigger enter, as opposed to on collision. So I think it's on trigger start and on collision enter. What's a game object? Kind of the minimum version of a game object. Again, if there was a question that kind of made it on there from the midterm, that might be in there. Now, what's the minimalistic game object that can exist? It's a dude that has a transform. This would be fair game. It's an important concept. I'm just trying to think how I would ask a question about this. I probably would, I guess it could come kind of in the form of what does it mean for a transform to be passed by value or something like that, where I would be looking for something along the lines of, if you passed a transform to a function and you change that transform inside that function, those changes are not permanent, because a copy of the transform was passed in, as opposed to, or rather, vector 3s. Yeah, that's the difference. So let me restate what I just said, because I said it backwards. Well, I said the wrong thing first. So transforms are collections of 3 vector 3s, right? If I pass a transform to a function, it gets passed by reference. So any changes I make to that transform, including his vector 3s, his internal vector 3s, will be permanent. Those will be felt outside of that function. As opposed to if I pass a single vector 3 to a function. Like if I pass into a function the position of a game object, just as vector3 position, and I make a change, that change would not impact the original vector3 that's part of the transform that I sent in, because it was passed in by value as a copy. Make sense? So vector3s act like, well, they actually are, the historical structs, and transforms are objects. If you're referencing this to like the 250 class, that type of thing. All right, make some sense? You should know what a renderer is. I could ask you to make a game object disappear after 10 frames, for example. So maybe inside of update, you would have to have you'd have a global counter. Inside of update, you would count up to 10. The end of 10, you would grab the renderer for that object and disable it. So turn enable to false. And then his renderer is off, so he won't show up on the screen. It's different than destroying him. The game object still exists in the scene, we just don't see it. And when you don't see it, it doesn't interact with other things either. So it is there, but doesn't act like it's there, but it could come back into play at any moment. I could ask you a question about raycasts. I don't know if I would ask you to program anything with a raycast. It's more of a collider type thing, so I would probably ask a more simplified version of a raycast. I would ask a more simplified collider question, probably if I asked you to write the code. But it's possible I could write a code that would show you a raycast and ask you, what does this do? Something like that. Because our real experience with raycast was on like the Diablo game, where it was kind of giving you the ability to click into a 3D scene. So it was doing like weird mathy stuff to say if I had a raycast and it hit the ground somewhere, because the idea was where you clicked, where you clicked on the screen, so you had a mouse point, then you raycast it to that mouse point to get you a space in the Z coordinate plane for where your guy should to move. So it was doing some mathy stuff behind it to translate your two-dimensional click on on a flat screen into a three-dimensional position that you may have clicked on the screen. I wouldn't ask you something like that. It's more of like a mathy trick where you would sit there and mess with it for a little bit until you kind of got it working the way you wanted it to work. But it's possible I could give you a raycast code example that was more straightforward than that. Not some crazy math stuff going on in me. The goal wouldn't be you telling me what the crazy math stuff does. The goal would be, tell me if this raycast collides with something, just in general.
Are you doing like pre-read code and then you ask regular questions?
Oh yeah, it'll be all random. I'm thinking probably something like, there'll be more programming in this one than the first one, or at least more reading code too. So things that look like programming. I'd say at least half the test will be those kinds of questions. So maybe there might be 2 or 3 questions where you write code, and then the rest of them would be either, here's some code, tell me what it does, that kind of stuff. Yeah, so probably only 2 or 3 questions where you write stuff. Or maybe like a single liner doesn't count in that. I'm trying to think. Maybe it would. Maybe that would count towards like the 3, where I'd ask you, to like show me how to get a component or something like that. Definitely be able to understand the character controller. This would fall more into the category of, I might give you code that does something with a character controller, as opposed to ask you to write code dealing with the character controller. Code that I'm asking you to write are going to be more with Unity fundamentals. Getting game objects, disabling stuff, asking if a collision, asking if you collided with something that matched a tag you were looking for. Fundamental type things, where character controller is kind of a specialized thing where if you were going to use the character controller, you'd look at some example code and use it. So questions about character controller would probably fall into something where I would show you working code and say, what does this do? Something like that. So perhaps at the high level, it would be a reasonable question for me to ask about character controller, kind of what are the advantages of that versus just using a standard game object for your player with with an animation model or something. So, the character controller handles a lot of the movement for us. It also gives us more granular control over collisions. Where on the body it's colliding, that kind of stuff. So it would also be possible I could ask a high level question like that, where what are the advantages of the character controller? So not a coding question, but more of a understand why a character controller might be used. I wouldn't ask you to write something like this, but I might find give you an example where we're doing something where you're giving like a couple of options to one of the settings for a game object that uses masking with the OR, and you should know if I show you something that has ands or ors that this is saying, oh, I'm applying both of these options to that guy. So not about the math behind the masking. But so in here, I wouldn't ask you to do like bitwise ands or ors, even though that's what's technically happening. That's more of a 325 question. But if you did see a line of code that was setting two options for a game object, and it had the little and symbol between it, you should know that that is giving it both of those options because they're being masked together. Observer design pattern. So we see this. I mentioned this earlier. I do like design pattern stuff. It's possible I could ask you the high level question of what is this dude, but it might come in the form of like the on trigger enter, or rather on collision enter function. Which design pattern is this an example of? Something like that. So that's the observer design pattern. The observer design pattern says that it's a good idea to be productive and then be notified when some event occurs. So we're being productive inside of like update and stuff. And then at some point when we collide with something else, we get notified that a collision has started. And at that point in time, we start dealing with the logic associated with that. Well, observer design pattern is not only related to that, but that would be an example of it. So on collision enter is us relying on being notified when a collision starts, right? So that's an example of the observer design pattern, where instead of us inside of update saying, did I hit something, did I hit something, did I hit something, did I hit something, we instead are productive inside of update. And then when we do actually hit something, somebody yells at us and tells us that we did so that we can go and deal with it then. So that's where like on collision enter comes into play. So it would be like an example of Unity's implementation of the observer design pattern. Just like Unity's implementation of MVC is the public variables in our scripts so that they show up over on the Unity side. And then also on the script side, we can extract components from things in our Unity side based on the game object that owns the script. So we can say like get component and get parts of that. Know about animators. I wouldn't ask you to write any code dealing with animators. Again, it's not hard code. You're just changing the state, but it's possible I might give you some code that does something, that if a certain button is pressed inside of update that makes you, so we think about it in terms of the Diablo game that makes you take a swing, that you might play the swing animation, that guy, something like that. So, I might ask you to kind of make the assumption that, okay, well, it says play animation attack. Guy probably is going to be swinging on the screen. something like that. Again, understand that difference between pass by reference, pass by value. It won't be it probably won't really be represented on the exam. It's more of like a 250 type of question. For us, the importance is more of just really understanding that some things that we pass to functions might be passed by reference versus might be passed by object, and it's important we consider that. So that's more of just a using Unity skill set. Since the tool does so much for us, sometimes we need to throw our own logic into the equation and say, okay, well, this guy, I'm sending this guy an entire game object. When I make changes, are those permanent? They would be. But if I'm sending this guy just a vector 3, if he makes changes, are those permanent? They wouldn't be. I might ask you that specific type of question on the exam if I needed an extra question, but I wouldn't ask you a generic question of pass by reference versus pass by value. It's more of like a 250 topic. Same thing with polymorphism. Parallel arrays type thing. I wouldn't have you write code that used parallel arrays, because now we're starting to get into a kind of longer code chunks. It's not that you shouldn't be able to do it, but it would be possible that I give you code that does this. I mean, I think what the code, how it might come on the exam is I might give you kind of like a program, like a working script, and then I might have several questions that ask you things about that script. So you'll have kind of a single code base that you'll have to answer questions about different parts of it, something like that. So it's possible I might have two arrays in there that are related to each other, where I have two different 5-bucket arrays. One is a collection of tags. The other one is a collection of vector 3s for its position or something like that. That would be, so if something's tag matched the tag from bucket 2 of one array, his position would be the position represented in bucket 2 of the other array. That's the whole parallel array example. So it would come more in the form of you reading code and knowing what that's doing. Okay, so procedurally generated stuff. That's what we've been working on most recently. And so this is, so leveraging prefabs, understand that this allows us to have kind of either we could have randomly generated type things, or we can also have kind of builders. Like when we first looked at this, we said, oh, well, what if I want to put a staircase here? And I want to put another staircase here, another staircase here. I can have a function that will, a script that generates staircases that I could give a position to, and then a number of steps, and whether it's going up or down or something like that, and have it at runtime go ahead and generate those stairs for me. As an example, that might be a handy type thing, because if you were kind of creating a stairway game object, that might be a little bit tedious. I mean, I'm sure there's stairway game objects you can get out there that are somewhat malleable, but you might be stuck with like a 6-step thing, because if you start stretching it out, then the steps get longer and stuff like that. So it might be beneficial for you to be able to replace stairs with something else that might be of interest. So that's kind of our pros and cons of that. So these start coming into questions where they could be represented on the exam at the high level. What does it mean for something to be procedurally generated, and what are the pros and cons? That type of thing. This goes back to the, way earlier, but this is when we first really started looking at scale, because we started thinking about things as being children of other things, at least a lot more. So understand that idea of scale and how the scale value is relative to its parent. So if something has a scale of 1 to 1 to 1 for X, Y, and Z, that is relative to the current size of the parent. Whereas if it doesn't have an official parent, then it's relative to the entire scene. So that's when it acts what we would maybe call normal. But if it goes into a parent that's shaped weird, a 1-to-1-to-1 puts it as the same shape as the parent as a starting point for scale. Well, not same shape necessarily, same relative scale. So if the parent is extra wide, let's say, and you had a scale and you had a scale of 1, you would also be extra wide because your scale of 1 is relative to what the parent scale is, not the full world scale.
Oh, why would it like?
Well, what do you mean? What like why does it work that way? Typically, you are not going to be changing. Well, it's not real common for you to be changing like the scale of or who the parent of something is at runtime. Although we have seen that it reverts back, right? So it doesn't just keep it as 1-to-1-to-1. It actually converts it to the appropriate scale relative to the full screen. So really the reason it's going to have this scale like this is because you can move around an entire transform that has a bunch of children and everything drags with it. So everything is relative to the parent from position to scale to rotation. You know, if I rotate the parent, everything inside gets rotated as well. So those are just tightly linked. And one of the consequences of that is the pieces of the transform are also related. All right. I wouldn't ask you a specific question about local scale. When we manipulate scale programmatically, we manipulate it based on either local or lossy scale. Lossy scale has a performance benefit. Local scale is, you know, I'm going to set this to the exact dimensions based on my parent. And if you're doing a lot of movement animation type stuff where things are moving around, that's a lot of additional calculations for local scale stuff. Lossy scale lets us do that stuff at a higher performance. Okay, but I wouldn't ask specific questions about those. That's something we kind of just touched on, kind of unimportant for. I don't know how I'd ask a question about it. It's kind of the punchline, so probably wouldn't have a representation. Understand the concept of world space. You know, where this, if you don't specifically have a parent, if a game object doesn't specifically have a parent, its parent is assumed to be the world space. You know, that is everything in the scene. So the scene has that XYZ coordinate system, where if we put something at 0, 0, 0 in the scene, it'll be right in the middle of the scene, as opposed to if we put something at a position of 0, 0, 0 inside of a parent game object, it'll be 0, 0, 0 relative to that parent game object wherever it is on the screen. It wouldn't get sucked to the middle of the whole screen. It would be the middle of that parent. Okay, so world space is kind of what we think about as the full XYZ coordinate system of the scene. All right, so data representation languages. It would be reasonable for me to ask a high-level question about these. You know, what is a data representation language? What's the difference between HTML, XML, JSON? So kind of talking about HTML kind of being maybe one of our original standard ways of representing things, XML being based on that, and then JSON being the kind of the newer cool kid.
Like JSON is like a newer way to do XML.
Well, I think you could say from a data representation perspective, JSON has caught on as the more popular way of representing data. So doing something similar to what XML does. But the reality is JSON is JavaScript object notation. So it's actually been around as long as JavaScript has supported objects. Because that's how the JavaScript programming language represents objects internally, is using JSON. So now we're saying, oh, well, if that worked for JavaScript, why can't we just externally move that and now use that for passing information about objects between multiple programs? So realistically speaking, you can think of the data representation aspect of JSON as being the newer way of sending object information between more than one program as opposed to XML. But really, they have both been around for a while, and they're both based on other things. So XML came out because it was like, oh, well, HTML is kind of neat that it's using this tag-based, open-close tag-based structure for representing web pagey stuff. Like, I wonder, what if we wanted to represent other things like that, but that wasn't web pagey? Could I use something that looks a lot like HTML? Sure. So let's call that XML. Okay, extensible markup language. JSON is just another approach to how do you represent objects textually, and then it looks a little bit cleaner. There's less fluff. When we looked at the two of them, XML has a lot of extra taggy looking things and very little data, where JSON seemed to have less extra. So, like, there's an example of an XML patient record, and there's that same patient record in JSON. So a lot simpler, right? I could have something on there dealing with some of these things. It's, borderline maybe more of a networking type thing, but the reality is that especially next semester, we're going to be doing network based games. So you have multiplayer and that kind of stuff. And this idea of the client server model would be somewhat important. The only reason I would ask it maybe in terms of how the internet works, how the web works, is because we specifically looked at that example. Okay, where we have this protocol called HTTP that we're using to communicate over the internet. Here's our client, our web browser. Here's our server, our web server. The client sends something in the HTTP language to the server. The server processes that request and sends a response back. Make sense? So I wouldn't ask you deep details of that, but it's possible that this concept might make it onto the exam in one format or another. Because there will be probably at least two questions dealing with the high-level nature of data representation languages. Why do we need them? Sharing information between two. If we have one computer program running here, that's our computer programs operate in terms of objects, right? Objects and logic and things like that. Then we have another computer program over there, and we need these guys to talk to each other in some way. It might be beneficial for us to come up with a way of representing our objects so we can lob them over the internet to the other program so that he can take it, unpack it back into objects, and do logic stuff with it. Make sense? So that's kind of the stuff we've been dealing with more recently, but understand the context of when we might use a data representation language. Just understanding that XML and JSON lets us represent things, that's interesting enough, but why? Is it just because we like to dress things up in different ways? Why represent it as a comma separated values when we could just make it look like JSON or make it look like XML just because? There's a purpose. There's a reason why we're packaging up in kind of an easy to transmit format. Strings are easy to send over the network. Okay, entire objects are less, actually, we could say less easy, although you probably could. There was a technology with Java called RMI, Remote Method Invocation. Java had an implementation of it. Remote Method Invocation was really a design pattern type thing, where you could actually call a method in another program, passing it parameters, and it just, quote, magically worked. But what was happening under the scenes is those parameters were getting serialized. They were getting sent over the network and all that stuff. So it was doing the same stuff we're doing now. It was just happening kind of automatically or automagically, something like that. Okay, but we should certainly understand why we might put something into a JSON or an XML format. What would be the purpose of that type of thing? the idea of protocols, fancy way of saying language. Right now we're using the English protocol, right? Okay. Typically our real life protocols are technology protocols are far simpler than our natural languages. So they're not doing nearly as much stuff, but they're used to have unambiguous communication between programs on the internet, something like that, or programs on a network, or even programs within a single computer. I probably wouldn't ask you any specific questions about web browsers, but this get and post stuff might come into play when we talk about using the HTTP protocol for maybe having two programs to communicate with each other. Like, why invent a brand new language when one already exists? So we talked about RESTful APIs here. So, we have this language, this protocol that's been around since the beginning of the internet called HTTP, Hypertext Transport Protocol. And we might decide, hey, why don't we go ahead and leverage that language for having our two computer programs talk? So we can actually send stuff using gets and posts. And, so post lets us create something new. Get lets us retrieve existing data. Update lets us update something that's there, and delete gets rid of something that's in the database. So, kind of leveraging an existing language and, using it for a different purpose. Like right now, we're kind of, we're leveraging English to teach computer science. Okay, where you could also use English if you were a third base coach in baseball, to yell at the guy who's batting or yell at the guy who's on first or something like that. So now you're applying that same language to a whole different problem, something like that. That's a much more complicated language, but now we're saying, okay, well, HTTP was originally designed for the problem of web stuff. But now we can go ahead and use that language for doing other things. Now, I wouldn't ask something very specific about this. This would be more of a high-level question because we didn't do anything specific with it. We kind of did the first part of it and saying, hey, I can turn my objects into JSON. I can turn my JSON back into objects. Now, since I've proven that, nothing keeps me from taking that JSON, sending it to another program somehow. Maybe through something like a RESTful API, having that other program catch it, and then he can turn my JSON back into objects on his side. So we proved that we can do the to JSON and back from JSON, right? Move. So nothing keeps us from doing one direction on one program and the other direction on a completely different program. And we would use that protocol in the middle to send that data between the two. Does that make sense? So we didn't do an example of that. Next semester we will when we do we'll have to have a server and do our multiplayer stuff for like a first-person shooter and that kind of stuff. So you have dudes running on the screen being controlled from different computers, and that information needs to get sent to all those different clients so that we can update our screens. Go ahead.
I wasn't here earlier before, but when you're talking about like the whole JSON, you have the exam. Are we like the kind of, should we know how to, or are we have to write, say, turning us whatever input into JSON and then making us serializing it into
I might ask you to, given this object, so maybe I have a class. I give you some code, and here's a class, and here's an instance of that class. Here's two instances of that class, maybe even in an array. So here's an array of 2 or 3 instances of that class. Show me what the equivalent JSON, the representation of this would look like in JSON. So you'd have to write JSON code. So know the syntax of JSON. So that's a different question than saying write the code necessary to convert this to JSON. Instead, I'm asking you to say, write some JSON. That is the equivalent of what this array of objects is. Make sense? So this is kind of what we were just talking about, this HTTP protocol. These would be questions at a high level, not a specific type thing. All right, so this is kind of where we were talking about more of the, how do we use that example, that client server example from how the web works to have two programs send information to and from each other. So they agree upon a language, a protocol to use. Maybe they go ahead and use a language that's been around for a long time, like HTTP, since it can be abstracted through this idea of like, hey, RESTful APIs, we can use our 4 functions that have been built into HTTP since day one to accomplish generic things. So maybe that's enough for any 2 programs to talk to each other. So that's kind of the idea there. So now we can say, well, we agree upon a protocol, but maybe that protocol is HTTP. Kind of makes some sense. Okay, as opposed to we roll back 10 years ago or something, we maybe would have said that, well, 2 programs here, we're going to agree upon a protocol, and it's probably going to be a language we're going to make up. So we're going to have our own little code language that only you and I know how to speak. But now if the same program here wants to talk to, maybe you and I, maybe you're a bank. Okay, and I'm a program that integrates with the bank. So me and Chase Bank over here are we've agreed on a top secret code that we use to talk to each other. But we probably don't want Wells Fargo to know about our secret language. So now me and Wells Fargo, we're going to come up with our own alternative language or alternative code or something like that. So that would be more of like proprietary one-off languages, protocols for you to use between things, which is all fine and dandy for that one application. But now if you want to go and write another application where data gets sent from program 1 to program 2, you now have to rewrite the parsers, the serializer and the marshaller, the deserializer, for going to and from that made up language. Does that make sense? As opposed to us using JSON as a base and maybe HTTP as the transmission protocol.
So are there so many just like, I guess, companies and serial programs?
Well, if you look at anything recent, go to any internet-based company and just see, ask if they have a public, just do, Twitter API, YouTube API, PayPal API. They're all going to be RESTful APIs. They're all going to be based on HTTP. So that's become kind of the standard. But if we would have asked a similar question to that 10 years ago, we may have gotten a different answer. There might have been some that were starting to use HTTP. Before we had RESTful APIs, we had this kind of halvesy attempt at a generic API thing called SOAP. But even that didn't have a consistent implementation, so you might still have to tweak your code a little bit to work. But you go back even a little bit farther than that, and everything was one-offs. If I wanted to talk to Twitter, I had to learn the secret code that Twitter wanted me to speak to it with. And that was going to be not compatible with the way I might talk to PayPal. Something like that. So you'd have to write one-off programs for each of those integrations, where now, you can have, here's these 15 lines of code that talk to Twitter, and now I can take those same 15 lines of code and talk to PayPal, except the endpoints just change. Maybe Twitter is post message and read messages, where PayPal is send money or request money. Different endpoint, but we're using the exact same protocol for requesting it and sending it. So you wouldn't change your transmission code; you just change your request. So just one word or something like that. Because sending money with Twitter isn't a thing, right? You can send them that message, and their API is going to spit back and say, I don't know what you're talking about. I mean, I understood what you were asking me, but I don't have a function that does that, so no. Or empty JSON is usually the response, but something like that. Okay. So obviously, this is a kind of the basis for the entire next class, right? So the next class, I think I mentioned, outside of class, you're going to be working on a RPG. So kind of looking at the next level of what you're doing in class now for kind of user load screens and just, a different kind of movement base. But then in class, and then also for homework for the second half of the semester, we're going to be creating a network-based game. Where you're going to have kind of first-person shootery stuff where you have multiple people running around and you see them on your screen, and really thinking about the network protocol type stuff, thinking about, how do I store different pieces of information kind of in the cloud somewhere? Where does user authentication come in? How do I keep track of people's hit points or what their inventory is, and all sorts of stuff like that? And also game management tools. So if you think about a game like World of Warcraft or something where you have like a collection of weapons that are available. Where does that collection get stored? How is, when somebody loots a boss, we have something called like loot tables. How does that work? How does a loot table get implemented? And, what are the percentage drop rates for different things? And where does it pull the information from and all that stuff, right? So you got to consider that, you think about the early days of World of Warcraft, for example, you would have 40 people in a group. And you'd have a single boss die. And so these are 40 real people on 40 different computers in a single shared experience. A boss is killed, some loot drops. Now you have to manage that whole thing of who's allowed to grab the loot, what loot is for what classes. There's all sorts of management stuff behind the scenes that we don't necessarily think about, but those are things we're going to look at in the next class. Make sense? Because, actually, at the end of the day, let's think about just what you learned in this class in terms, we've gotten somewhat proficient with Unity, right? We recognize there's a whole bunch of stuff you can do in Unity that we maybe haven't done yet. But as a generic tool, we know how to use Unity now, right? Could you, so if replace World of Warcraft with whatever your favorite video game is, okay? If you had somebody who was a good enough graphic artist who could make the character models that are in those games, could you program pretty large portions of those games now in Unity? Yeah, you know how to do the animation stuff and things like that. So yeah, you could make those things. You want an enemy to spawn on the screen? No problem. And he acts this way. So a lot of those things from games that you play now, you can kind of think about, how might that be implemented, right? Okay, but now we almost always think about our games as network-based games. Or at the very least, if it's a single-player type game, you think about the complexity of the game that we didn't really do much with in this class is all that other stuff, your inventory system, saving your state of things between games, all that stuff. Get what I mean? There's like that whole half that we're missing. Because using Unity was just a skill set. Fine, you're going to get better and better and better at it over the years or something like that at doing different things. But really, just based on what you learned in here, there's a pretty large percentage of things that you can now do in Unity that's only limited really by your imagination and artistic design prowess, right? So for me, it's stick figures, but yeah, whatever. So in any case, the whole next class is kind of based on this slide. We might have more than one computer talking to each other. So how do we do that? And this is where we were talking about standardized ways of talking. So HTTP maybe being the protocol that we choose for that. And then this is where we got into the serialization stuff. So turning stuff from an object representation. So the way programmers write stuff. We have any programming language, Java, C#, Python, and we have an object or something. Okay. As a programmer, we like to work with it in that form. But at the end of the day, if we need to send that someplace else, or maybe we're not even sending it to another computer program. Maybe we're just storing it. So we're storing the current state of the game, right? Maybe you're storing the current state of your inventory. So you have a single player game and you open up your backpack and inside there you have all your stored weapons and things like that. And the next time you launch the game, you'd like to kind of pick up where you left off. You don't want to have to recollect all the stuff you've ever collected. If we go back to kind of the old school games before they were even on the network or something, and before they maybe even use databases, the old school version of a database was just a file. So when you closed the game, when you exited the game, it wrote the current state of the game to a file. So maybe we can just dump the serialized version of our inventory, so like a JSON version of our inventory, into a big file, right? And then next time we launch the game, it reads that in, it deserializes it, and then we have our inventory filled back up, pick up where we left off. Kind of make some sense? So that's a use of JSON without ever leaving the computer. That's not for network use. That's just for saving a game, which has been around for forever, right? For a long time. I'm sure the early games you couldn't save, but it's a pretty common trait now of our games. What if every single time you had to sit down and play a game, you had to just finish it? I guess for a couple of you, that might not actually change your experience. It seems to be whenever there's a new, very popular video game that comes out, I see my classroom attendance goes down by about 10%. And then they come out of their cave 3 days later after they finished beating the game. All right, so this is where we started talking about representing the department in JSON. So we representing our department in objects. So we had a collection of rooms, length, width, height, and that had a collection of room objects inside of it. So that's where we decided here's a room collection object, here's a room object. We're going to have a room collection object, have a linked list of room objects, and we're going to make these guys serializable, and then we just use the internal JSON utility, which made it real easy to produce things like this, and then also go back to our objects from the other side. Make sense? So even though we can write this by hand, and even though we could create a program it's a lot easier to write the program that generates the JSON than it goes from the JSON back to objects. Both of them are doable, but the JSON back to objects requires us to write a JSON parser, go through this big, ugly looking string and pull the pieces of information out. That makes sense? So it's in our best interest, since we've agreed upon a standardized representation like JSON, we might as well use the built-in JSON utility that's in almost every programming language today. Java can do it, Python can do it, C# can do it, blah, 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 blah. So that's even another reason, right? You choose JSON or even XML, most of them have XML as well. You choose one of these standardized data representation languages, and now you don't have to worry about writing the pieces to serialize or deserialize. It's a pretty big perk, right? Because then you just focus on your programming, and if you need to save stuff as JSON or send JSON to some other program, you just use, it was one line of code, right? JSON utility.toJSON. That's pretty convenient. Or JSON utility.fromJSON. Also pretty convenient, but we had to go, last class we looked at the caveats associated with that, right? That assignment was not a hard assignment, but we saw that you lose some of that control when you're going from JSON, a representation like this, back into an object representation, because all you're getting is the public variables of it. Anything that was private, you're going to have to reinitialize. And that's what we had to do last class. Make sense? All right, so understand the nature of objects. When we talk about JSON, what we're actually storing is the public fields. That is what gets stored with JSON. The data associated with an object, not the logic associated with the object. When we think about methods, when we write methods, those guys are reusable chunks of code, right? This is an old 200, CSC 200 idea. So you learn how to write a method or a function that's a reusable chunk of code that we write once and can use multiple times. Those methods are part of our objects in our case here, C#. we don't have to reload those. That's the methods themselves are not stored inside of JSON because they're part of the structure of our objects. But what differentiates one instance of an object from another instance of the same object is the data of that object, the fields. That makes sense? That's the information that JSON's holding, is the information about individual objects, individual instances of an object. So that's what gets sent. All right, so the JSON stuff is all about this field category here. And then specifically for JSON utility, only the public fields get automatically dealt with. Private fields, we're effectively saying we are in charge. So that's why last class we had to go and do some additional work after recombobulating our JSON because we needed to reconnect up those few game objects that we needed to actually get this thing to show up on the screen. All right, questions about any of that? Questions about the exam in general? So it should be pretty easy.
What are the questions?
I already told you. I told you every question. Wouldn't that be worse, though, if I gave you the questions and you still did poorly? At least you have an excuse, like, well, that was harder than I expected it to be. So that's why I sucked at it. Questions, comments, concerns, bribes. So the next time I will see you is at 5 a.m. next Thursday. I'm waiting for Jacob to freak out. The back Jacob. He was no 7:30. 7:30 a.m. next Thursday. Okay. Like I said, it's a 1-hour exam. It's going to be designed to take that, but you have the full 2 hours to take it. So make sure you're here on time. So it's not a time crunch at all. You can sit there and stare at it for 2 hours if you want. There shouldn't be any sort of race condition at at the end of class. All right. I will see everybody next Thursday. Plenty of room in the front row of chapel. I will save a seat for you.